Hello! Today we're going to be looking at running the ESP32 code on an emulator. The technology that we use to do this is called QEMU, or Quick Emulator. And we can go to a Google search and we can look for QEMU. And here we will find some information about QEMU or QEMU. And you can see over here under user mode, it tells you can run various different types of architectures, including the ESP32 architecture extension, which is pretty cool. Now, if you're looking for what's going on behind the scenes, we can go through to the GitHub repository of Espressif. And if we have a look at this, and under this repositories over here, we can search for QEMU. And we can see that there is a fork of the original QEMU that has especially been designed to run ESP32 chips. We can also go through to the wiki over here and get much more information. And if you read this over here, it'll basically tell you that you need to compile it on your machine. Now, I have a Windows machine and there's quite a few prerequisites that you'll need to basically install, and becomes a bit of a pain in the butt because there's quite a bit of work involved. However, if you're using the Espressif VS Code extension, we have a Docker container that we can use. So if you're brand new to this stuff, there's a couple of things you're going to need. Firstly, just very quickly, head over to my course, learnesp32.com, go to the course and look at the free videos, specifically the environment setup, and go ahead and actually install your environment. Then you're going to have to head over to Docker, and you're going to need to go ahead and read up on how to actually install Docker on your machine. So if I look over here, I'll notice that I have Docker started. Okay, so let's get cracking with this thing. Here I have VS Code opened, a brand new VS Code instance, and I'm just going to hit F1 and I'm going to say ESP-IDF new project. If you don't see it, you can just go ESP-IDF : new project. Let's go ahead and select that, and we'll give it a name. This is going to be QEMU test 1. And I'll put it into a temporary directory somewhere. C projects, my Spike directory. That's where I have all my play code. Now I'm going to just go ahead and say, choose this template. And I'm going to hit this extension over here. I'm going to choose the ESP-IDF, and I'm going to go ahead and say sample project and create project. And it's going to ask me, this has been created. Do I want to open it up in a new window? Yes, I do. Okay, brilliant. So here I have a brand new project. Notice that we've got this dev container over here. That is the Docker file that we need in order to run our QEMU instance. But for now, what I'm going to be doing is I'm just going to be writing a little bit of code. Okay, and the question is, do we have some IntelliSense? So let's have a look. So hash include ESP_log.h. It appears so. That's great. So let's go ahead here and create a while loop. So while true. So let's go ahead and print out a log. We'll say ESP_log I for log informational, and we have the option. The first thing tells me that we can put a tag in there, so we'll just put something like QEMU in there, and then essentially we can put in some sort of message. We say running QEMU count %d. We haven't got something there just yet, so let's go ahead and create something there. We'll say over here int count is equal to 0. Over here we'll basically say count ++. Then I'd like to add in a short delay. So to do that, I'll need to add the FreeRTOS libraries. Hash include FreeRTOS, FreeRTOS.h, as well as hash include FreeRTOS task.h. Then over here, we can say vtask delay, and then we can use the macro pdms 2 ticks, And over here we can put in the milliseconds we want to delay. I'll just put in 1000. Okay, so that is our code written, done. Now before we even try to compile this thing, what I'd like to do is actually open it up in my Docker container. As you know, it does have this dev container. So what I'm going to do is I'm going to hit F1 and I'm going to say open in remote location. So remote container, reopen in container. That's what I want. So make sure everything's saved, and let's go ahead and do that. And we can see that it's starting the dev container. All right, so it looks like it's now started up, which is great. So let's go ahead and open up our main again, and we can see our code that we have just written. And at this point, we can go ahead and build it. That's the first thing that we will need to do for running it in an emulator, is actually build it. So over here, you can see that you can just press that ESP32 build. That's one way to do it. My preference is to actually open up a terminal and then write the commands, which is idf.py build. And as this is the first time it's actually building this, it might take a minute or two. Okay, so it is now built successfully. You might notice that the IntelliSense has gone a bit wonky. If we have a look at what's happening inside our VS Code file, we'll notice that the C++ properties is all pointing to my C drive. And obviously, my Docker container doesn't know where my C drive is. So if you wanted to fix that, you could go ahead and actually find where the GCC extension or GCC compiler is, and essentially add that here, and then go through to the settings and change all these paths correctly. But that's not the point of what we're trying to do here, so let's not worry about that too much right now. What I am going to do is I'm going to create a new file here. Let's put it on the root, and I'm just going to call this commands, and we'll just make it a text file. So I'm just going to put the commands that I'm going to be running inside here, just so that we can actually see what we need to do. So the very first step of actually getting QEMU up and running is we need to actually combine all our bin files. If we have a look at the build folder, we'll notice that there's actually a couple of different bin files. The primary being this one over here, QEMU test1 bin. That's the bin file that was just generated by building this project. However, if we have a look at the flasherargs.json, we'll notice actually at this point in time there's actually 3 bin files, and it'll actually tell us where they are. There's the partition table bin, there's the bootloader bin, and then there's this one over here. Also interestingly is notice the offset of where they are. This is essentially where they would be written to within the actual flash. So what we need to do is we need to actually create a single file that represents what our flash is going to look like. Just to be clear as to what it is that we're trying to do, what we'll need to do is we'll need to create a file, and this file will need to be 4 megabytes large, because that is the size of my flash. Then starting at about 1000, wherever that is over here, we'll need to basically start writing in the bootloader. And that's going to happen at 0x1000 of this file. Then a little bit later, we need to write the partition table at 0x 8000, I believe it is. And then a little bit later, at 10,000, we need to write our app. So we can go ahead and actually get some Python or some JavaScript to actually put together a file like that for us. Luckily, we don't need to do that. There's actually a command that'll do it for us. And what I'll do is I'll just go ahead and paste this in here, and then we'll walk through what it actually does. So what this is doing is it's basically launching this ESP32.py, which is essentially a very common tool that we use with a chip, and you'll notice it's /./, which basically means I want to execute this thing. And over here we basically specify which chip it is we want, the ESP32, but it could also be the S2 or the C3 or whatever it is. Then we've got this command called merge bin, which is what we want to do. We want to merge all these bin files together. The output will be results.bin. That's essentially the new bin file that it's going to create with all the merges. All right. Full flash size is going to be 4 megabytes because that's how big my flash is. Then starting at 1000 hex, we're going to go ahead and get the build bootloader bin, which is build bootloader bin over there. Then starting at 8000, we're going to go build partition table.bin, partition table.bin. And then finally at 10,000, we're going to go to build QEMU test2, which is essentially on here, except for it's not QEMU test2, it's QEMU test-1 bin. QEMU test-1 bin. Yep, that looks good. And then flash mode, DIO, and then flash frequency, and flash size. So if we go ahead and put that in here, and I press enter, it says that it's written it. So let's go to the root of the project, and we'll notice over here I've got this result.bin. So that's my combined bin file. Okay, cool. So that's the first thing we needed to do. The next thing we needed to do is we need to basically run QEMU. And to do that, we're just basically going to look at this command over here. So we're going to run QEMU system extension. So this particular executable is actually recognized by this environment. So this is part of my environment variables already. So I don't need to go ahead and look for it. It's already there, which is quite nice because of this the way this Docker container has been set up. Right, we're going to run no graphic, machine is ESP32. The drive is going to be this result.bin, which is essentially what we generated over here. And there's some sort of other options as to how it should actually recognize this particular flash file. So I'm just going to copy that and I'm going to paste this in here. And if we did it right, we can see, yeah, it's starting, and we can see our count, 1, 2, 3, and so on. Okay, now, interestingly, I find it very hard. I don't know how to basically exit out of this. So I'm just going to go ahead and kill it. And there's essentially two more options that are of interest to us. The -s, lowercase, we'll put it into debug mode so that we can actually debug it. And -S means halt the execution, don't start it until you actually have a breakpoint on there. So let's go ahead and run this one now. So I'll just go ahead and create a new instance or a new shell and run this, and we should see it start, but then it should just stop. So there it is. It's waiting for us. And it says your application is running on port 1234 is available. Okay, cool. Now our debugger is waiting on a port. We need a way to actually hook up a debug port or debug remotely on this particular port. Unfortunately, the expressive launch.js doesn't allow us to do that, at least not that I've been able to see. So if I go ahead and launch this, nothing happens. Oh, we just get this error. So what I'm going to do is I'm going to go to the extensions and I'm going to put in here GDB. And the one that we want is this thing called GDB LLDB. This one works quite well. So this native debug. So go ahead and install it. And once that's installed, let's go back to our launch.json and we're going to add a configuration. And now that we've actually got that extension, we'll see these GDB entries come up. And what we want to do is we want to connect to a GDB server, and we're going to be modifying this a bit. So you'll notice over here that we've got some IntelliSense for some additional stuff. The thing that we need to do is actually get the GDB path, and this is essentially going to be the extension GDB debugger. So let's go ahead and actually open up a new terminal, and we'll just go ahead and find it quickly. So I'll just go cd to the root, and then I'll say find. Look everywhere where the name, and this is where it gets tricky, is extensia -ESP32 elf -GDB. So let's go ahead and find that guy, and there it is. So that's the full path. So let's go ahead and copy that, and that'll be our GDB path. The request is going to be attach. The name, let's go attach to QEMU. Our executable will be the elf file inside our build. So that'll be, if we have a look for the elf file here, it'll be this one, QEMU test1 elf. So let's go ahead and just grab that name. So we can use the $workspace variable /build for the build directory /QEMU test1 elf. The target is going to be :1234. So that's essentially the default port for QEMU. Current working directory is definitely this workspace root. That's good. And we'll try it with this pretty print on. Let's see what happens. So I'm going to go ahead and save that. Now, just one thing before we end up here is this ./ needs to change to just / because it's not relative. It's essentially from the beginning of the root. So now that we've got that right, let's go ahead and save it. Oh, we don't need this terminal, so we'll basically go ahead and close that. And we're sitting over here and it's waiting for us to attach. So with that, let's go ahead and make sure we've got the attach to QEMU selected. And let's go ahead and press the play button. and we can see that we're hitting a breakpoint. And essentially we can F10 through that, and we can mouse over the count, we can play, and it'll come back, and we can go to our terminal, and we can still see the output over there, and we can see the local variables over here, and a little bit of the stack trace over here. Step over. All right, and that's it. So now we've seen how to set up QEMU with the breakpoint and run some ESP32 code as an emulator. I hope this video was useful to you and it potentially saved you some time. And if it has, please consider subscribing to my channel and liking my video. Other than that, please also consider supporting my Patreon account, as it will enable me to produce high quality videos like this. Thank you again for watching, and see you later.